Today we're going to look at systems of linear inequalities, guys. If you remember systems of equations, we were dealing basically with two equations and two unknowns. Now, when we looked at linear inequalities, we were shading a region, right? Shading a region. And we said that shaded region, or that half plane, if you will, was going to be the collection of all points that would satisfy the inequality. Now, today what we're going to start looking at is called systems of linear inequalities. And what we want to ask ourselves is, how can you graph a system of linear inequalities? Basically, two inequalities. So our goals for the day are to check solutions of systems of inequalities. I'll show you what that looks like. We're going to graph the systems of linear inequalities. We're going to write some systems of linear inequalities, and we're going to use those to solve some real-life problems. So I guess the first thing we need to know is this. What the heck is a system of linear inequalities? Okay? Basically what it is, just like systems of equations. How many equations did you have? Two. How many unknowns did you have? Two, an x and a y, right? So systems of linear inequalities basically is going to be the following. It's going to be two linear inequalities. I'm way off. Hang on 1 second. By the way, how'd wrestling go on Saturday? What was wrestling here, wasn't there?
That was a little kids' stream.
Okay, little kids.
Yeah.
You guys had to work.
Yeah.
I suppose you were here all day, huh? Oh, I bet that was a long day.
You gotta listen to parents complain.
Oh,
Why were they complaining?
Coach Homer almost getting in a fight with that guy.
Yeah.
That was great.
That was
Two inequalities, two linear inequalities with two unknowns.
Yeah.
So you're telling me it almost turned into WWE. That's what you're telling me. Almost turned into WWE.
Yeah, because his there's his parent and his kid went into overtime and his kid lost by it's kind of a sketchy takedown, but you could tell it was a takedown, and so his parent comes screaming out on the mat. He's like, "That's garbage! That's garbage!" And then he got into Coach Homer was reffing that match, so he got up in his face and he's like, "That's garbage!" And he wanted him to redo the call, and then the guy kind of calmed down a little bit. So then Coach Homer and the guy were like demonstrating what happened.
So the guy wasn't just escorted out of the building.
No, Coach Homer was punching him though.
I think there's a better way to know that. All right. So guys, as an example right here, we'll stay mathematically inclined here. An example would be something like this: 3x maybe plus 2y less than or equal to maybe 18. And then we might have another one where we have y greater than or equal to maybe 3x plus 7. Right? The reason that that's a system of linear inequalities is because we have two inequalities there, as an example. And we're going to look at what the regions would look like now. We're trying to find all the points now that make not just one inequality true, but rather both inequalities true. Okay? And then a solution of linear inequalities is going to be the collection of points. All points how many points, right, actually, how many inequalities do we have to satisfy now? One or two? How many inequalities are there? Two. So it's going to be all points that make, here's the key word. Here's the key word, both inequalities true at the same time. So all points that make both inequalities true. Are we good on that, guys? Okay, let me know when you have time and I'll show you what we're looking at here.
Okay.
Are we ready, kiddos? All right. So example 1 right here, checking some solutions. Tell whether each ordered pair is a solution of the system of linear inequalities. Okay. Here's our system right here. Here are our two inequalities. All right, I'm going to kind of make a T-chart up here for this. What's the first point they're asking to see if it's a solution for us, guys? Which point do they want to know for? -2, comma. Okay, I want to know, is this point a solution for this system of inequalities? Now, here's the deal. We're checking to see if points make inequalities true. Now, if I throw a point in, the first inequality turns out false. Is there any point in checking the second one to know if the point's a solution? There isn't. Now, you want stuff to be true all the time. Once you find something that's false, you're done with it. You'll know the answer is not a solution. So here's what we're going to do. We're going to take this 2, comma 1. We're going to throw it into the first inequality and into the second inequality. So this is for the point, -2, comma 1. Here we go. My first inequality, y is greater than 3x. So what are you going to plug in for the y value, guys? 1 greater than 3 times, what are you going to throw in for the x here? -2. All right, so my comparison for this is the following. We get 1 greater than, what is 3 times -2, gang? Okay. That statement true or false? 1 greater than -6, true or false? It's true. Positive is bigger than a negative, right? Been a long break, hasn't it, Marion? All right. So it is true. We all agree it's true? Everybody agree it's true here? 1 is bigger than 6 after I put it in, okay? So when I substitute -2, comma 1 into the first inequality, it turns out true. So to know if this is a solution to this system right here, we need to take and plug this into the second inequality. So what's going in for y on my second inequality now, guys? Here, no, we're still checking which point? We're still checking this point right here, right? So we're going to throw a 1 in for y again. For the second inequality, 1 less than or equal to. All right, the opposite of x, which would be what, guys? What would the opposite of -2 be when I plug that in here? Wouldn't that be +2? And then minus what value here? Okay, so I plugged in the 1 here and a -2 right there. This becomes 1 is less than or equal to 0. All right, so when I get that figured out, a comparison of two values, 1's less than or equal to 0, is that true or is that false? That's false. Okay? That is false. So when I substitute that point, -2, comma 1 in, does that make both inequalities true or not? Just one of them, right? So is -2, comma 1 going to be a solution to the system? What are you going to say? No, it's not. This is not a solution. Not a solution because one of the inequalities was false. All right? So let's check 0, comma 4 next. 0, comma 4. What's going in for y? 4 greater than 3 times 0. So this becomes 4 is greater than 0. True or false? 4 greater than 0? That's true. Check your next one. What are you going to throw in for y again, kiddos? 4 less than or equal to, this will become 0 minus 2, won't it? So 4 is less than or equal to 0 minus 2. 4 is less than -2. Is that true or is that false? 4 less than -2? It's false. Okay? That's false. So is this going to turn out to be true? False? So is that a solution or not? Not a solution, is it? Not a solution. So in other words here, you have to make how many inequalities true in order for a point to be a solution? 2 of them. Okay, so both cases here, are either one of those points a solution? The answer is what? The answer would be what? The answer is no. Okay, the answer is no. Okay, well, let's look at stuff graphically here, guys. Yep. right. Anybody else need more time? Perfect. Okay, well here we go. Kiddos, we're going to start looking at graphing systems of linear inequalities. We're going to go back to that situation where I'm going to say, what's the form? What's the boundary line look like? Draw your boundary line, figure out which way you're shading. That's all we were doing. So to do something like this right here, guys, I'm going to ask you this question. So forms, again, were slope-intercept, standard, which we're going to use most often, horizontal and vertical. Okay? So in this first one right here, to graph this, help me out, guys. What form is that in when you have just y and some number? And if you don't remember, you might want to have those 5.6 notes out that give you all the recall stuff there. Y and some number. You guys recall what kind of line that is? Somebody knows. Shout it out. Other way.
Horizontal. Horizontal.
Very good, Carson. Horizontal. It'll be horizontal. Talk to me about my boundary line for the solid or dotted. What's your sign here? Is this going to be solid or dotted?
Solid.
Okay. What we're looking to do here is find a collection of points that's going to make both of these true at the same time. So we're going to have a horizontal line that is solid. And this is where your rulers will come into play. So on the y-axis, what value do I want to run on down to? -1. Let me blow this up here a little bit. Run down to -1, which is right here. And then what kind of a line did I want through there? Solid, right? Let me draw this. Now guys, here's the big piece about graphing. Oh, I don't want that to be dotted, did I? I can fix it. How's that look, guys? You okay with that? All right, this is the part I want you to be careful about right here. I don't want you to shade anything until after you have both lines drawn. But what I am going to do is I'm going to figure out what direction I would have to shade here first in this example. Okay? Guys, this says all y values greater than -1. Would I be above or below that line? All y values, I want y to be greater than -1. That should be above. I mean, I can plug a point in. So for instance, if I plugged in 0, 0, just a quick reminder, if I plug this point in right here, you don't have to do this. That point is 0, 0, right? At the origin. If I plug that in, this becomes 0 is greater than or equal to -1. Is that true or false? Is 0 bigger than -1, kids? Okay. Here's what I'm going to tell you to do. We know we have to shade what direction then? Above, don't we? Don't shade just yet. All I want you to do is to say, maybe put an arrow like this to indicate I'm going to be shading up there somewhere. Okay? We know the points to satisfy both inequalities at the same time is going to be above that line somewhere. Okay? Anything down below here? The answer is not going to be there. Okay? It's going to be up here somewhere. Now, the second thing I'm going to do is come back and I'm going to graph this line. Guys, when y is all alone and you have an exponent like this, what form is this in? Is it slope-intercept, standard, horizontal, or vertical form? Slope-intercept, isn't it? How about your boundary line, guys? Solid or dotted here? It's going to be dotted. So let's do this. What is the y-intercept for this line? Careful. The intercept is 2. And then, Marion, what's the slope through that? Okay. So here's what I'm going to do. I'm going to go up to the y-intercept of 2. I'm going to plot that. Then a slope of -1 means to come down 1 and right 1. And then the line for that, is that going to be solid or dotted, kiddos? Okay, so let's go ahead and draw that. It'll look like this on your graph. Okay, now here's the deal. Here's the deal. We need to figure out what direction to shade for this graph. And what I like to do is the following. Guys, I'm going to do the following. First of all, there's 2 lines on here, right? 2 lines on here that cross. And what I'm going to do is this. I'm going to label my sections. I'm going to label this a section. One up here. Whoops. I'm going to label this section 1, section 2, section 3, section 4. Okay, I've got a section 1 up here. It's kind of above the solid line and above the dotted line. Here, 2 is above the solid line but below the dotted line. Number 3 is below the solid line and below the dotted line. Section 4, you see that small area right there, section 4, it's formed by these crossing lines, below the solid line and above the dotted line. Okay, so I've labeled 4 sections for those intersecting lines right there. Question would be this. Of the 4 sections that I've numbered up there, which 2 sections could possibly be solutions for the system of inequalities here? 2 or... Okay, we've got to be above. We already said based on this solid line, we've got to be what direction? Above it. So which sections are above that solid line to begin with? Section 1 and 2. So we know we're either going to be shading section 1 or section 2 here in a second, right? We need to figure that out. So what I'm going to do again is I'm going to take this point right here, 0, 0, and I'm going to plug that in for my second function. This becomes the following: 0 less than 0 plus 2. All I've done is taken the 0 for x and a 0 for y, plug those in, and I get a statement that says 0 is less than 2. Is that statement true or false? That is true. Okay, that is true. So hear me out on this. This point right here, 0, 0, in red that I'm pointing at, in relationship to that last line I just tested, the dotted line, when I go that direction to 0, 0, I get a true statement. So am I going to be above the dotted line or below the dotted line? Below that dotted line. Okay? You have to be below the dotted line and above the solid line. So which section does that limit me to then of the 4? Which one? Section 2. We're going to be right in here. So we're going to say the collection of points that's going to satisfy this is going to be that section right there. These are all the points that make both inequalities true at the same time. Now again, just shortcut right here. If you ever have a y and the arrow is pointing away from y, if you're ever pointing away from y, you're going to go above the boundary line. And if you ever have a y value in here where the arrow is pointing at y, you're going to go below the boundary line. And maybe this is a better way for you to remember. Check this first one right here, guys. Is the arrow pointing away from y or pointing at y? Away, isn't it? So what direction do I want to go for this line? Well, what direction did we say? Above it. And then this one right here, is the arrow pointing at y or is it pointing away from y? The second inequality. It's pointing at it, so go below the second boundary line. So go below this line. Well, above this line and below this line puts you in that section number 2. Okay? All right, so I want to show you something with decimals because decimals can help you with this as well again. But the first question that I have for you, are you okay on that right there? Everybody okay on that? Okay. The next question I have for you guys then is this. In decimals, if I would pull decimals here and say, what's this look like graphically here? You're going to see a graph completely different than what I have up here because all I'm doing is shading one time. In decimals, they're going to talk about an area that's shaded twice or a double shaded area. And here's what it would look like to you. All right, I need a volunteer to read that first inequality for me. When it loads up, my computer's been really slow lately. I don't know about yours. How about you guys? How they've been doing lately? Slow? Okay, what was that first inequality? Somebody want to read that for me? Wasn't it y greater than or equal to -1? Notice right away, what do they go ahead and do? They went ahead and shaded everything right away. Where I said, let's just put an arrow up. We know we're going to be up there somewhere. Okay? What was the second inequality they asked you to do? Plus 2. Okay, graphically then, this is going to be an area that's shaded twice. Now, if you notice right here, you have some blue and you have some red. The red is everything above, the blue is everything below. Where's the overlap occur then, guys? Where's that overlap occur? Well, didn't it occur right in here in section 2 that we called? Okay, so your graph here in decimals, if you're checking stuff, you need to kind of look for this maybe purple color right here. It's where the two graphs overlap. Okay with that? Everybody see that? All right. Quick question then. Would this point right here be a solution to the system? It'd be one of them. One of them, right? So we would have to say no because one of the inequalities would have turned out false. Is this point going to be a solution? Reason being, it's in the area that's shaded how many times? Twice. Okay, this is a section that's the solution. So understand how my graphs look in your notes compared to what it looks like in decimals. Just understand that the section you're looking for is the one that gets shaded twice. All right. So let's look at another one here. Questions so far? Anybody? You guys are still on the turkey hangover? Still tired? Yeah, I am too. All right. Let's check this one out. Guys, you have a couple of things here where graphing a system of linear inequalities can do some goofy things. Right? Both of these are in standard form. So we need to do the opposite of A over B for slopes. And we need to do the C over B thing for intercepts. So let's take a look at this first thing right here. Guys, my slope on this graph right here for the first one, what is your slope going to be? What would the opposite of A equal? How many x is this?
Negative.
1. So wouldn't my slope right here be negative 1 over, isn't the b value really negative 1? Or negative 1 times y? Would you guys agree with that? Okay. So the slope's going to equal negative 1 over negative 1, which is what value? Positive 1, right? How about my y-intercept? C divided by b. It's going to be 2 over, what kind of 1? Which is negative 2. So let's graph that. Solid or dotted line, kiddos? Solid or dotted line for my first inequality? Negative. These are 1x and 1 negative here. Slope. And then C over B is my y-intercept. Alright, so the y-intercept, what value was the y-intercept? Was it negative 2? Right? And the slope was positive 1, rise 1, run 1. And dotted line, correct? Okay, good enough. Guys, in the graph, or I'm sorry, any inequality I should say, find your y value. Everybody see my y value here? If I throw 0, 0 in here, I'm going to do that. I'm going to throw 0, 0 in. I guess 0 is greater than 2. True that or false that? False. So which direction am I going? This is a false point. Which direction am I going? Below. Okay, so answer's going to be down there somewhere, right? My next one then. Help me out with this. What's the slope going to be again? What's the slope going to be again? So slope will be 1. Whoops. And your y-intercept, how about your y-intercept? What will that be? Careful. Negative 3 divided by, just be 3, wouldn't it then? Okay, now, I'm gonna go back to something here in a second because something that I told you is kind of contradictory, and we'll see if you can catch on to it. But for my graph here, the y-intercept would be positive 3, and the slope would be 1 again. Solid or dotted on that line, kiddos? Look at the inequality sign on the second inequality. Solid or dotted for the one we're graphing now? Solid? Okay. So let me draw that. Oh, shoot. So, oops. Yeah, that'll work. Guys, if I plug 0, 0 in here, this says 0 is less than or equal to negative 3. Is that true or false? It's false as well, isn't it? So wouldn't I go away from 0, 0 here? Guys, where are they going to overlap at? Where are those shaded regions going to overlap at? That's false, so you go away. Right? The 0, 0 is below it, right? 0 is bigger than the negative number. Are they going to overlap? Not going to overlap. So if there's no overlapping of regions right here, can there be a solution? No. This would be one of those ones where there's no solution. Now I want to make sure that I'm very clear about what I'm telling you here, and kind of plugging points in to check the shade. That's great. Anybody see a problem with what I told you about the shading above and below with the rule? I said something like this. If y points away from, or if the arrow points away from y right here, we shade what direction? Above. Well, look at this right here. Find your y. Everybody see the y right here? Going away, isn't it, from y? So it means shade what direction? But notice over here, what direction did I go for that dotted line? Above or below? Below. Okay, wait a minute. Why did I do that? Well, here's the reason. What kind of a y is this really? Positive y. What kind of y do you have right here? Negative y. All right. So maybe somewhere in the notes down here, jot this down. If you have a positive y and the sign points at it, you're going to go below. Okay. Now there are times in standard form where that y might be what kind of a y now? Well, what kind of a y did we have in these guys? Positive or negative? What kind of y's do you have in this system? Okay. For negative y's, it's just the exact opposite. If you have a negative y and your sign points away from it, then go below. If you have a negative y and the sign points at y, then go above. Okay, so those 4 rules right there can save you a lot of time in terms of where to shade if you want to get those down quickly. So check this out, just in the second example right here, or the second inequality. What kind of a y do you have, guys? Positive or negative here? Negative. Is the sign pointing at a negative or pointing away from a negative? Pointing at a negative. So it means go what direction for that line? Is that what we did here? Okay. Very important right here. If you want to have kind of a cheater way to shade stuff, that's how you do it there. Okay. So what are you going to say about this right here, guys? Where's the region at that's the solution? Well, if one goes above and one goes below, like this and this, no region's going to overlap. So what do we say about the solution here? No solution. Since the regions didn't overlap. No solution since the regions didn't overlap. Let me know when you've got that down. It's kind of a tough one. Guys, get the general idea here. Systems of inequalities. You're basically looking for the collection of points where the two lines do what? Say in this case, two regions do. Overlap, you bet. That's the key word. Good. All right, well, let's look at this last page and see if we can't figure some stuff out. I want to work on writing a system of inequalities for this. We'll look at an example. It's real life. I'll be done here for the day. Guys, we need to work on writing a system of inequalities here. So anytime you have to write system of inequalities, my suggestion would be the following. Anytime you have to write something, I would say put in slope-intercept form. Okay, let's take a look at the solid line. Let's deal with the solid line first. Take a look at the solid line first. Guys, we got to write a system of inequalities such that the shaded region would be here in relationship to these two lines. So don't worry about the shaded region just yet. Don't even worry about the shaded region just yet. Okay, so let's write an equation for the boundary line slope-intercept form. What is the y-intercept here? 4, isn't it? So the y-intercept's 4, right there. How about the slope through that? How far up and how far over do you run from point to point? 1. So do you guys agree that the slope on that is 1? So what I'm going to do for this first inequality is write y. What kind of a y did I put down here? Positive or negative? Positive. Okay? And then I'm going to put the other part of this in slope-intercept form, the 1x plus 4. Now guys, in relationship to that boundary line, y and the 1x plus 4, is that shading above or below it there? Above. I should have left those up here. Why didn't I do that? I'll do this again. Positive y, pointing away, go above. Positive y, pointing at y, go below. Negative y, going away, go below. Negative y, pointing at, go above. Let's see. That shading is above that solid line, isn't it? And it's a positive y. So above positive y, what sign should I put in here according to this? Greater than. Do I want just greater than, or do I want something else with that? What kind of line was it? What do I need to put under here then? Greater than or equal to. That's the first part. That's the first part. Okay? Make sense there? All right. Look at your second boundary line. What's the y-intercept on the second boundary line? The dotted one, if you will. -1, how about the slope through that? -1 also, isn't it? So we have y compared to -1x minus 1. Slope's -1, intercept is -1. Let's see. In relationship to this, is the shading above or below? Above. Let's see. A positive y above. What sign should I put in here? Greater than. Do I put a line down here this time? Do I put the equal part in here this time? Why not, McKenna? It's a dotted line. Okay, so your system is this. Instead of giving the inequalities to you and say, hey, graph the system to find a collection of points, it's going to give you the solution to that. You're working the exact opposite. They say, hey, here's a graph. What's the system of inequalities that would work for this? You guys have this down right here. Does this help right here? I have a cheat sheet. Does that help? You have that down? Okay. All right. Last example here quickly, and then I don't even remember what time we got. 20 after, is that right? Okay. Let's look at a real life example here. Volunteer, read that for me. Go ahead, Parson. All right. You have at most 7 hours to spend playing soccer and swimming. You want to spend at least 2 hours playing soccer and more than 2 hours swimming. Write and graph a system that represents the situation. How much time can you spend on each activity? Okay? What two activities are we doing? Soccer and swimming. So I'm going to let X and Y represent some stuff. I'm going to let X represent the time that you, how about swim? Is that okay? So X is going to represent the amount of time that you are swimming. What's that make Y then, guys? Y is the amount of time that you're going to play soccer. Football in some countries, but soccer in America, right? They call it football over there? So, okay. So do you get mad when we call it soccer? Do you like the word soccer better than football?
I would call it football when I was a kid.
Okay. All right. Do you like college football in Iowa?
But I still don't understand football.
Oh, no?
Yeah.
Oh, that's good stuff.
Hands and just call football.
Yeah. I don't know. All right. I guess that's a valid point, Miriam. I guess I never really thought of that. All right, there's some things we want to know. How much time do we have to spend, first of all, doing both together? At most 7 hours. It means we can spend exactly 7 hours or what?
Whoa.
7 hours or less. So if I spend the times, if I add these two times together, they have to add up to be something less than or equal to what? Everybody agree there? All right, so that's 7 hours. The amount of time X, the amount of time Y added together has to be less than or equal to 7. Secondly, it says you want to spend at least 2 hours playing soccer. You want to spend at least 2 hours playing soccer. That means 2 hours or what? More. Okay, what represents the amount of time for soccer? Y. So we're going to say Y has to be greater than or equal to how much time?
2 hours.
Okay, to play at least 2 hours, that means 2 hours or more. The amount of time Y for soccer has to be greater than or equal to 2. It also says, and you want to spend more than what? More than 2 hours swimming. Okay, 2 hours would work. Would 3 hours work?
Yeah.
So I want that amount of time for swimming, which is which variable? X. We want X to be greater than or equal to what?
3 hours.
More than, what's the word?
2 hours.
2 hours, right? Holy smokes. I've been sitting here talking about systems of inequalities, and there's only been 2 inequalities, and all of a sudden Parsons thrown this real life example at us, and wouldn't you know it, there are how many inequalities up there all of a sudden? Not 2, but count with me, because that doesn't count. 1 inequality, 2 inequality, 3 inequalities. Oh boy. Let's see what this looks like. Okay. Guys, what form is this first one in? Standard, right? Help me with the y-intercept. 7 divided by really what? 1. What is the y-intercept on this?
Is it appropriate?
Okay, how about the slope? Opposite of A over B. Opposite of A over B, what is it? Anyone? Come on, guys. Slope, slope, slope. -1, right? Down 1 over 1. And we're going to have a solid line for this. Let me get my solid line in here. Shoot. There's my solid line. Let's see. Y positive or negative in this inequality? Positive, sign points at it. Positive, sign points at it. What direction are we going? Below. Okay, I'm not going to shade that in just yet. I just know that I'm down in here somewhere. All right? This next one right here is nothing more than a horizontal line at 2. And this is nothing more than a vertical line at 2. So the y greater than or equal to 2 is going to look like this. It should be a horizontal line at 2. Above or below that line that I just drew? Above or below? Above or below? Above. So we're up in here somewhere. So can you guys kind of visualize where we're at so far? Okay. And then the last one, x is greater than or equal to 2. That's just a vertical line at 2. That's going to look like this. Ah, shucks. That's that vertical line. You guys, we really haven't talked about x greater than 2, but give me a value that's bigger than -2 that would make this true. 7. Is 7 to the right of the vertical line I just drew, or to the left?
Left.
To the right. So I would shade this direction. Guys, kind of describe to me what section are you going to shade to make this collection of points work? Where are you going to shade at? What shape? It's the middle. It's that middle triangle right here that you're going to shade. You're going to shade right in here and say, hey, all the points that would satisfy this inequality would be the points in here. Okay? So guys, here's a question. Looks like if I go right 4 and up 3, I can be on a solid line. Can this point work right here? Can that point work right there on the line?
Yeah.
It can.
Solid.
Can a point work in here?
Yeah.
Looks like to me that's the point, right 3 and up 3. 3 and 3. Can I spend 3 hours swimming and 3 hours playing soccer? Would this work right up here? No. Wouldn't. Okay, it wouldn't. So in something like that where you have 3 inequalities, typically you're looking at the shape in the middle. It's formed by all the lines that intersect. Okay? So, kind of a quick crash course on systems of inequalities. We'll get some time tomorrow to work on some things. We got a lot going on in here tomorrow. Big test on Wednesday coming up. Guys, did 5.7 already show for you?
Yeah.
Okay, I put down due Wednesday for that one. So my hope tomorrow is when we come in here, we'll start with questions on stuff. Want to give you a lot of time to get some stuff done. Anybody need to see anything up there again or have any questions? All right. If you guys would make sure the rulers get put back up here today. We've got about 10 minutes. If you want to go ahead and get started on that, that'd be good. I'm going to shut this down.